Hi, in this video, we're going to show you how to deploy an application for text analysis on the GCP, the Google Cloud Platform. The purpose of our application is to find the most frequent N words, where N is defined by our user. The application can deal with both large and small datasets, depending on our user's choice. So for small datasets, the application will use an efficient algorithm to find the top N words. On the other hand, for large datasets, the application will use the Hadoop MapReduce to do the analysis. Now, I've already uploaded my code from the local to the GCP bucket. So the next step is to copy these files from the GCP buckets to the GCP virtual machine. So now, as you can see, there are 4 Python files downloaded. The first one, GCP small, will be the file for small datasets. And the mapper.py and reducer.py will be the codes for MapReduce for large datasets. And notice that I also have already installed the NLTK package displayed as the NLTK_data. You will need this for the small dataset because the algorithm will use a lemmatizer and stop words from the NLTK package. To install the NLTK package, run this command in your terminal. Since I already installed it, I will not run it now. Okay, so next, let me show you how to use our application. So let's start with the small dataset first. When the user want to use this, they will just type in python3 main.py to run the driver code. And they'll see the following prompt. They will have to specify 3 things in a line. The first thing is whether the dataset is large or small. The second is the number of N words they want to see, the top N, and the directory to the datasets. So we will type in small for small datasets, and top N equals 5. And then we will have a directory for the small datasets. And you will see all of the files in the datasets, and it will output the top 5 most frequent words. And so then let's proceed to the case for a large dataset. So this time we will have large 5, and we will have a new directory for the large dataset. And so what it does in the backend is it will first copy the data to HDFS, and then it will run the Hadoop MapReduce using the data on the HDFS. So while it's running, let me explain the architecture for this MapReduce. So here we use the n equals to 10 X example. So the Hadoop MapReduce will split the dataset into a different data chunk. And for each chunk, a mapper is assigned. And the mapper will find the local top 10 for this data chunk. And it will output the word and the count for these top 10 words. And so then we will have one reducer to find the global top 10. And it will output the global top 10. And as you can see, the MapReduce just finished. And so the top 5 words, that will be the global top 5 words, will be thou king, serve the Lord, with their count correspondingly. And so now let's take a look how the code works. So let's take a look at the main.py first. As you can see, the first step is to check the first argument provided by the user. If the user says quit, then the program will quit immediately. If the user says small, that means small datasets. It will first start a subprocess, copy the small datasets to from the user's bucket to our virtual machine. And once that's finished, we will determine the directory of the datasets in our virtual machine. And also we'll determine what's the number of n. And then it will start the algorithm finding the top n by calling this class and creating this class item called top n words from the GCP small. So now let's take a look at the GCP small.py. So here we have the class top n words, which stored the capacities that will be used for our heap. And it will also store the data path for the small data sets. And it will also store it in dictionary. So the first thing to do is to read all of the data from the small data sets. So it will open all of the files in the small data sets, and it will read each line. So each line is a line of string, and it will split that lines into a list of words, and it will process those words. There are two things to mention here. The first one is it will only contain those words that are not the stop words. The stop words is provided by the NLTK corpus. The second thing is that it will also process those words to be the base form using the lemmatizer from the NLTK as well. An example would be MER will be converted to B, and then cars, and cars will be converted to R, car. Eating, eats, ate will be converted to eat. And so once it has all of the words cleaned and processed, it will update the counters in the subobject. And once that's all finished, it will use a min heap to determine what are the top n words in the dictionary. The reason why we use the min heap here instead of directly using the most common n in the counter is that the most common n runs in of n log n time, whereas if we can find a min heap with a capacity of k, where k is defined by user and n is the total words in our dictionary, then the min heap can reduce the runtime for calculating the top n words from n log n to n log k. So it will first read all of the word and their counts from the dictionary. And if the heap is not full, that means the length of the heap has not reached its capacity, then we'll just keep pushing the count and the word into the heap. Once the heap is reached the capacity, we will compare the root of the heap of the min heap, which is locally the least frequent words in the heap. Compare that to our current word. And if we find that our current word is more frequent than the root of the heap, then we will replace that. Notice that in this case, each replacement will take log k time. So then for n words, the total runtime is bounded by O of n log k. So then this is our efficient algorithm for small data sets. So now let's move on to the large data set case. So here, if the user chooses the large, then the first step is we will start a sub-process that copies the data in the large data sets provided by the user to HDFS. And once that's finished, you will receive a message saying your data has been copied to HDFS. And then you will try to run the Hadoop MapReduce. And once that's finished, you will receive a message saying the MapReduce has finished. Here, the logs of Hadoop MapReduce is suppressed on purpose because I don't want to show that full long list of messy loggings. And so then once you receive the MapReduce finished message, there's another sub-process that will collect the results from the new output folder. And then the final thing will be showing you the top n words. So now let's take a look at the mapper.py. So here the mapper.py contains a class called mapper. The class basically has a list of stop words and a counter. And just like the small data sets, it will first process the words from each line. And then it will split it into a list of words, and then it will process those words to contain only the letters and ignoring all of the punctuations, as well as ignoring all of the stop words. And so once that's finished, it will also update its counter. And then once we finish this loop, the counter inside the mapper class will have all of the counts for this data chunk. And so then we will use the mapper counter's most common function to find the most common end words. And we will output the message in this format, the word followed by a tab followed by the count. And so then let's take a look at the reducer. So after MapReduce shuffle process, we will have all of the words grouped by together with their volume counts. So inside the reducer, there's a class reducer that will read all of the lines, and it will split that into the word and count to determine each word and count, and it will update its counter again. And so once it has finished updating its counter, we will use the most common words, most common function again to determine what's the most common end words. And here it will print word followed by the count, which will be seen by the user. So that will be the final print function from the reducer. And so then that's all for this video. I hope you like this video and find it useful. Thank you.